Alright, today's video here is on vectors and vector quantities. When you finish watching this video, you should be able to explain what is a vector quantity and a scalar quantity. You should be able to explain why it is important to consider the vector nature of quantities. Now, vectors are quantities or things that have both magnitude and direction. A magnitude might be a new word for you. Magnitude is simply a measure of how much. An example of a vector quantity is velocity. Velocity is how fast and in what direction. And it's the how fast part, the number of meters per second, that is the magnitude. That's the how much. What is your velocity? How much is the magnitude? And then what direction? Now, a second kind of quantity is a scalar quantity. Scalar quantities have just magnitude, like just an amount. And an example is mass. You don't say you have 5 kilograms north, you just have 5 kilograms. Now another example of a vector quantity is displacement. Displacement is the change in position. Another way of saying that, write that symbolically, another way of saying that is to say how far are you from where you started and in what direction. A similar but different quantity that's a scalar quantity is distance traveled. That just asks or says or tells you how far did you go. Now let's see the importance of distinguishing between vector quantities and scalar quantities. Here's a city. These are the blocks of the city. And I'm going to take a walk. I'm going to start here, and I'm going to tell you that I walk 3 blocks and then 3 blocks. Now, do you care whether to consider the direction of my travel or not? Well, it depends. If you only want to know how much exercise I've gotten, for example, perhaps you don't care what direction I go. So I could go 3 blocks and then 3 more blocks, and you would know that I had a total of 6 blocks of exercise. So in this case, the distance that I traveled, 3 blocks plus 3 blocks, 6 blocks. On the other hand, if you wanted to know where I am, well then you need to consider the direction. That is, you need to consider the vector nature of what I'm doing. In other words, you need to consider the displacement. And in this case, 3 blocks traveling, let's say, east, north, west, south. 3 blocks east and then 3 blocks north equals a total displacement of 3 times the square root of 2 meters. So in this case, it definitely matters what question you're trying to answer. How much exercise did I get? You don't need to worry about direction. I get 6 blocks of exercise. Displacement? Well, where I am? Now you need to consider the vector nature of that walk. Let's do a couple more examples here. Let's say I walk 3 meters and then 3 meters. Well, now the distance that I walk is again 6 meters. Excuse me, 6 blocks. So I got again say 6 blocks of exercise. My displacement is also 6 blocks. I am 6 blocks from where I started, 6 blocks to the east to be specific. And one last example, what if I walk 3 blocks north and then 3 blocks south? In this case, the distance that I traveled, the amount of exercise I get, is again 6 blocks worth of exercise. But my displacement is now 0. That is, how far am I from where I started, or where am I located? Now it matters if I'm asking that question that I know what direction I travel. Therefore, it's important when you care about where you are and what direction, it's important to care about the vector nature of these quantities. Vectors consider both magnitude and direction. Scalars consider just the magnitude.